Welcome to All About Math series.
Hello, my name is Savannah. In this video, we'll be discussing graphing quadratic functions. Let's first review what the standard form of a quadratic function looks like, and say that we are given an equation that looks like this. The first thing that we would do is label our a term, which is the term in front of the x squared, and in our case is a positive 2. Our b term is the term in front of the x, and in our case is a negative 4. And our c term is the term with no x's, which in our case would be a negative 6. We'll go ahead and label each one of our terms off to the side. And the first thing that we are going to look for is whether our graph opens up or down. Our a term will determine this. If our a term is positive, our graph will open upward, and if it's negative, it would open downward. Because our a term is a positive 2, that means that our graph will open upward. We'll next look for our vertex using the vertex formula. We have a formula to find our x value, which is negative b divided by 2a. And once we find that x value, we'll plug it into our original formula to find our y value. Let's go ahead and use our formula, negative b divided by 2a. And in our case, our b term is going to be negative 4, and our a term is a positive 2. On top, we'll have a negative 4, which will make a positive 4. And on bottom, we have 2 times 2, which is also a positive 4. 4 divided by 4 is 1, and this means that our x value of our vertex is positive 1. We'll now go ahead and plug in our x value to our original equation and solve for our y value of our vertex, which will be negative 8. So our y value is negative 8, and our vertex is the point 1, negative 8. We'll now go ahead and look for our y-intercepts, and our y-intercepts occur when our x value is 0. So we'll go ahead and plug in 0 to our original formula for each one of our x values. We'll get negative 6 at the end of this. That means that our y-intercept is negative 6. And notice here that our y-intercept and our c term are exactly the same number. That's because our c term, the term with no x's, will always be our y-intercept. We'll go ahead and look for our x-intercepts next. And notice here that we have the second power, which is our highest exponent. That means that we can have at most 2 x-intercepts. Our x-intercepts occur when our y values are 0. We will use a type of factoring, which is a times c. Here, our a value is a positive 2, and our c value is a negative 6. And 2 times negative 6 is negative 12. We will now look for the divisors of negative 12 that add up to be our b term of negative 4. And in our case, it will be negative 6 and positive 2. Negative 6 times positive 2 is negative 12. Negative 6 plus 2 is our b term, negative 4. We will now replace our b term, negative 4x, with negative 6x and positive 2x, because negative 6x plus 2x is negative 4x. We still have our a term, 2x squared, and we still have our c term of negative 6. We'll go ahead and group our first 2 terms and group our back 2 terms. And from our first 2 terms, we are going to pull out a GCF, the greatest common factor, which in our case will be 2x. We'll write what is left over after we divide the 2x out of our equation, which is x minus 3. We'll go ahead and copy that x minus 3, leaving a small space, and we'll look directly above it and ask ourselves, in order for x to look like 2x and negative 3 to look like negative 6, what does it have to get multiplied by? And in our case, it will be a positive 2. So our 2 factors are x minus 3 and 2x plus 2. The terms that we copied and the 2 terms we pulled out. We go ahead and set our factors equal to 0 and solve for our x's. That means that our x-intercepts occur at 3 and negative 1. We'll go ahead and graph. The first point that we are plotting is our vertex. The second is our y-intercept. And the third and fourth are our 2 x-intercepts. We'll go ahead and connect our points with a U-shape because we are in the second power, and that gives a U-shaped graph. And next, we'll state the axis of symmetry. The axis of symmetry, we will look at our vertex, specifically our x value, because this x value cuts our graph in half. So our axis of symmetry is when x is equal to 1. We'll next look for our domain, and because our graph will go on forever towards negative infinity and positive infinity, this means that our domain for our graph is negative to positive infinity. Our range is our y values, bottom to top. Once again, we would look at our vertex, but just at the y value of our vertex, which is our lowest point on our graph, and in our case, it's a negative 8. And our graph will go up forever towards positive infinity. So our range is from -8 to +infinity. If we are asked, our function is decreasing on an interval, well, our function is decreasing on this side. It's from -infinity until our x value of our vertex, which is 1. So our function is decreasing from -infinity until 1. The function is increasing on the opposite interval, which is from our x value of our vertex, which is 1, until +infinity. Thanks for watching this video and tune in for the next one. Have a good day.
It's a wrap for today's episode of All About Math series. Thanks for watching. If you enjoyed this video, don't forget to hit the subscribe button. Until next time, keep learning, stay curious, and we'll see you in the next All About Math episode.